In this video, we're going to look at momentum. Now, momentum of a body of mass m kilograms having a velocity of v meters per second is mv. It is measured in ns, or newton seconds. So you would just say it would have maybe 47 newton seconds would be its momentum. So momentum, very importantly, momentum is the mass of an object times its velocity. So if you have something with that which has a fixed mass, its momentum can increase if you increase its velocity. If the velocity of a body changes from the initial velocity u to the final velocity v, then its momentum also changes. And we'll see this later on in our series of videos here. Change momentum has a special name, but change momentum is equal to the final momentum minus the initial momentum, which is mv minus mu, or m upon v minus u. So since momentum is what's called a vector quantity, the direction matters. So the direction in which it is going matters. We're going to look at two examples now of this. So in this example it says a particle of mass 3 kilograms is travelling with a velocity of 4 meters per second. Calculate the momentum of the particle first of all. So for A, all you're doing is you're saying momentum is just equal to mv, and its mass is 3, its velocity is 4, so it's just going to be 12, and remember the units are newton seconds. For part B, it says the change momentum if the velocity of the particle increases to 8. So we're just going to do change momentum is mv minus mu. I'll just do it this way. So it's just going to be 3 times the final velocity, which is 8, minus 3 times the initial velocity, which is 4. And that's just 24 minus 12, which is just going to be 12. And again, newton seconds. The last example for this video says find the change momentum of a body of mass 2 kilograms when its speed changes from 6 meters per second to 50 meters per second in the same direction. So we're just going to say then, we'll do a wee diagram here just to show what's going on. So we'll have our initial. It's just going like this. There's your body, and it's going at 6 meters per second. And then your final. And it's still going in the same direction, but it's increased for some reason. It's increased to 50 meters. So you just say your mv minus your mu is 2 times 15 minus 2 times 6, which is just 30, minus 12, which is just going to be equal to 18 newton seconds. Now part B is a little bit different. Part B, again, your initial, it says it's going at 5 meters per second. So it's going at 5 that direction, but the final then, it changes direction. So the final, it's actually going 3 meters per second the other way. So for this one, we'll say our mv minus mu, the mass is still 2, and it's 2 times the final, which is 3, minus 2 times my initial. And if I've taken my final as positive 3, my initial then, because it's going in the opposite direction, is minus 5. It's going the other way. So that's going to be 6 minus 5. That's going to be 6 plus 10, which is going to be 16 newton seconds. And that is the end of our first video in this series. So next video, we're going to look at what's called the conservation of momentum, which is basically that the total momentum before impact is equal to the total momentum after impact. But that's a wee introduction there. In this video, just to momentum. Momentum is mv, the units are newton seconds, and your change in momentum is your initial momentum, your final momentum, sorry, minus your initial momentum.